Exercise 5. In this exercise, we're going to take a look at computational fluid dynamics. And essentially, we're going to use a software that's embedded inside SolidWorks known as FlowExpress. FlowExpress is actually a computational fluid dynamics software, and this is a light version that comes standard with SolidWorks. There is a more heavy-duty version just called FlowWorks, and we'll take a look at that in several minutes. But for right now, let's take a look at what we have here. Our goal today is to create that ball valve that you see on the screen. We're going to design it. It's a very simple little model, and we'll learn some modeling techniques, as well as we're going to put some little caps at the end. Now those caps actually serve the purpose of allowing us to select faces for the inlet and the outlet, and assign a pressure to the fluid that's going through the orifice. In this case, we also twist the ball valve internally a little bit so we could simulate turbulent flow. Turbulent and laminar flow are the two types of flow you can generally witness with this type of software. Laminar flow means that it's in layers, it's very organized, and it flows through nice and easy. Turbulent flow is when you get it swirling around, kind of like a tornado effect sometimes internally, and that can cause different types of things, cavitation and also bubbles and things like that. So sometimes it's undesirable. But in this case, we're just going to do some simple simulations of that. We can also measure the velocity and changes of temperature and such. Okay, so our goal, again, create that model. So let's go ahead and start a new part file inside SolidWorks. Select part. Okay. We're going to go ahead and select the front plane and start our sketch. And I'm going to go ahead and turn my background to plain white. What I'm going to first start off with, because it's a symmetric ball valve on the outside, I'm just going to draw a vertical center line about 3.5 inches high. Double click to cancel the chain. And then a horizontal center line about 6 inches long. And then hit escape on your keyboard. Take the line tool and on the center line, around 5 inches along to the left, click and drag out a 1 inch, maybe 1.5 inch line vertically. Then draw one that's about 1.5 inches horizontally. Hit escape. And now what we want to do here is we want to mirror this across. So I'm going to hold Control and select the vertical and horizontal object lines. And then I'm going to select the vertical center line, holding Control. And go to the Mirror Entities tool. Looks like a bell-shaped icon at the top. It should mirror it over. The next thing you can do is go ahead and select the 3-point arc. Glide up to the vertex on the left here and drag it across to the right and connect it to the vertex on the right. Drag this up, click, and then hit escape. Now the dimensions we're going to have on here, first of all, go to Smart Dimension. And let's put a dimension from this horizontal line here to the horizontal center line. Now cross down below the center line and it will give us a simulated diameter dimension, which is supposed to be 3 inches. So I'm going to type in 3. Now go ahead and select this vertical line on the left and select the vertical line on the right. Drag it straight up, and that's going to be 8. If you start to see some changes in your geometry, if it looks like it's tying a knot, this next dimension should eliminate some of that. Just go ahead and select the arc, dimension that at 3 inches. Then hit escape. Finally, after you hit escape, hold the Control key and find the center point of the arc. Select it one time. Hold Control still and select the origin. And on the left, you should find an option under Add Relation to merge. Go ahead and select Merge and hit the green check mark. One last thing we're going to do is we're going to go ahead and close the base. So I'm going to select the Line tool and just draw a horizontal line directly across to connect this and hit escape. We're ready now to revolve this. Now we want to revolve it 360 degrees around the horizontal center line. So select the horizontal center line or the object line. There's mine too. features in the upper left, the features tab on the strip here, and then find revolve boss face. If you don't see a preview, it might be an indication that you have a fragment of geometry or an opening or a gap. Or you could just move your pointer over here and click within that little area and it will revolve around it. Otherwise, you might have to fix your sketch. There's a possibility, like I said, you could have a fragment. Go ahead and hit the green check mark to apply. The next item of business here is to actually shell it out. So as I'm going through the book here, on page 50 in the 2011 manual, what we need to do is shell it out at 0.3. So for that, go to and find the shell command up here. Now be careful, do not hit enter, do not hit the green check mark because you might shell it out inside without putting the ends on. So make sure you set to 0.3 over here on the left. Select both areas where there's going to be an opening. So on both sides, click on those faces. And hit the green check mark to apply. And just to verify, you can rotate it around and make sure you can see through it. Another way to verify is to go to section view. And as long as it's set to your front plane, you should be able to see the internal openings there. Hit the red X to cancel it. If you hit the green check mark, you just have to turn off section view. The next thing we're going to do is we're actually going to add the detail on the inside. So to do that, let's go ahead, again, we're going to select, in this case, we're going to select the top plane. And with the quick launch, find sketch, and now hit your space bar and go normal 2. And it should rotate you. Just double click on the normal 2 option. And here you're going to probably want to go to wireframe. So right here where we see the little shaded blocks, find wireframe, which is at the bottom. And now we could go ahead and we're going to convert this edge to usable geometry for our sketch. So click on the silhouette edge here in the center and find convert entities up here. Click on it. And then on the left, you'll have to hit the green check mark to apply. The next thing you can do is take the line tool, so select line, glide up here onto this curve that we just converted. Right about here in the upper left, somewhere, click, and drag this across. Drag it pretty far, actually drag it out beyond the boundaries of your actual geometry there. And then hit escape. Now what we need to do is we need to trim that off and we need to extend this. So find the trim entities tool. Click on it and you'll find a couple options. We're looking for trim to closest. It's at the bottom on the left. Click on what we don't want, which is this little fragment of the sketch here. And then to extend this, you're going to get the tip of your pointer over the black edge, hold the left mouse button down as you do this, and drag it to the blue line, and it will close in on it. Now you can just click on the excess on the right, then hit escape. The next thing we're going to do is we're going to go ahead and find the centerline tool. If you hit the little arrow to the right of line, you'll find centerline. Click on that. From the origin, drag out a nice long horizontal centerline, just as long as it pokes out a little bit like that. And then go ahead, double click to end that chain, or right click to end chain, and then go ahead and click on the origin again and drag out an angled line. Right about there. Then hit escape. Now we're going to add some dimensions to that, so go find the Smart Dimension tool in the upper left and select both center lines. And between the two, find that whatever the degree is, and click and type in 20. hit escape on your keyboard. Now we need to make these two lines parallel. So the 20-degree center line, click on, and hold Control and select this blue line, holding Control. Now once those two are selected, on the left you'll see several options for relationships. You want to add a parallel relationship, so click on the parallel button and hit the green check mark. Finally, we want to give ourselves a diameter for the center here, so go to Smart Dimension again. Select the blue line, and then select the 20-degree angle center line, and drag your pointer below the center line, down below here. Don't want to drag it up or else you get a radius. Drag it down, click, and that's going to go, and we're going to change it to 1.8. And we're ready to go. Hit escape, pre-select your 20-degree angled center line, and then go to Features on the upper left and revolve boss base. Now we don't get much of a preview here, but what you want to make sure you do is turn off an option called Merge Results. Uncheck that little box there on the left. Don't want that on, otherwise it will connect the two and our ball valve will be like it's welded together. In this case we want it to stay separate, and also make sure it's set to blind at 360 degrees by the default. Hit the green check mark to apply. And then click somewhere on the screen. And now you can see what looks like the internal ball that's slightly tilted at 20 degrees. Alright, at this point, now we're going to go ahead and go back to shaded mode. Find the shaded with edges option. And if you want to rotate this a little bit, you can actually see the ball valve inside there. Or I should say the ball inside the valve. Now go ahead and from the feature tree you could select, or better yet, just go ahead and click on a ball and find the beach ball that appears on the quick launch toolbar up here. It's called Appearances. Hit the little arrow, and we could apply to the whole part the body, which there's two bodies in there. Remember, there's the ball inside, and then there's the outside casing, or just a revolve feature. We actually want the whole part. And click on this little Edit Color button. It's a little gray button. Click on that. Now, once this pops up on the left, you'll see you'll have an option to change this to transparency. So on the left here, just drag this down, this little bar, until you see there's a number of options. Actually, we want to go to Advanced. See, there's Basic and there's Advanced. Click on Advanced. And we see Appearances. We can change colors. What we're really looking for here, though, is the ability to change transparency. And here it is. Under Illumination, there's a tab, Illumination. And Transparent Amount. Go ahead and grab the little bar and drag it until you could see, with just a slight haze, all the geometry. I put it at about 0.8. And then hit your green check mark. Okay. Now if you don't like the shadow effect on it, if you're getting a shadow or if you want the shadow effect, it's right over here. There's a little, looks like a little TV set or a little monitor. It's called view settings with the hand pointed over to it. You can turn off shadows in shaded mode. Or turn it on. Let's go ahead and save what we have. Go to the diskette or File, Save. And you'll want to save this on your C drive. And find the temp directory. And call this E3. And if you're taking any other SolidWorks classes, you might want to put FEA afterwards. E3, FEA, just so it doesn't get confused with your other exercises that you might do in the SolidWorks classes, which are typically E3. And hit save. The next element we have to add are the caps. To add a cap, just go ahead and zoom up here to this face and click on this front face. With the quick launch toolbar that appears, there's sketch. You want to click on the sketch button right next, just to the left of the little set of eyeglasses. And then take the circle tool, the upper left here, find circle. And from the origin, glide up to the origin, make sure you snap to it. You get a little orange dot in the center, click and drag out a circle. Now make the circle just a little bit smaller than the actual outer diameter. And we'll go ahead and dimension that. Click on the dimension, smart dimension, drag out your dimension, and go ahead and put in 2.6 for the diameter. Now you can go to Features, on the left, upper left here, and go to Extruded Boss Base. We're going to make these 0.3 thick. So on the left, line at 0.3, and hit the green check mark. Okay. And then we could copy that over too. Although if you want, you could actually change the color a little bit, but I'm going to leave it the same, pretty much the same. Now to mirror this across, find the right plane in the feature tree, select it, hold Control and select the Boss Extrude at the bottom of your feature tree, which is that little cap we just added. So holding Control, you just need the right plane, the Boss Extrude, and then go up here in the middle and find Mirror. And in this case, you're going to go ahead, we got feature to mirror, just go ahead and hit the green check mark. Now one of the things I neglected to do here on the very first one is I should have turned off merge results. So to fix that, find the Boss Extrude one, right click, and when you right click on it in the feature tree, find edit feature, it's on the quick launch, it's the very top left icon, the little yellow block, the green block coming out of it. And we should turn off merge results here, so uncheck that because we don't want it connected to the part. Now we might get a little error on a mirror. Just right click on the mirror and edit feature. In this case, we have a feature to mirror. Click on that and hit delete on your keyboard. Instead, actually, let's see if we can do a geometry pattern. Click on a feature and then geometry pattern and then feature scope. We'll do selected bodies, make sure that's turned on, and select that cap. Hit the green check mark to apply. We still get an error. Let's just delete that mirror. So instead, hit escape, right click on it, and find delete on the right, the option there. It's going to ask you, are you sure you want to delete this? Hit yes. Okay, we'll try that one more time. Click on the actual boss, or you can select it here from the feature tree. Either one is fine. Hold Control and select the right plane. Go to the mirror tool. And we want bodies to mirror. Click on bodies to mirror here. And then actually we should make sure that that's selected. Reselect the Boss Extrude as the bodies to mirror. Hit the green check mark. So that's the key, is make sure you get bodies to mirror. Okay, make sure you save what you have. Now we're ready to go ahead and start working with the Express Computational Fluid Dynamics software. Under Evaluate, go ahead and click on Evaluate. You'll find FlowExpress Analysis Wizard. Go ahead and select it. My it's just loading. It takes a minute to install it. Depends on how fast your computer is. You might actually have it come up much faster than what I have here. Okay, and the FlowExpress really walks you through the process here. On the left, you can see there's options. What we want to do is just hit the little arrow here for next after welcome. Now go ahead and click on View Fluid Volume, and you'll see it automatically picks up on the enclosed area between our two little caps. That's it's giving us a preview there. Just go ahead and hit next. Now, with the light version that we're using, or the express version, you only get water or air. With the full-blown version, you get a selection of materials to choose from. In this case, we would just want water, and then hit next. Okay, now for this, we have pressure. Make sure pressure is selected. And then what you're going to need to do is be able to select the cap on the left side, but on the inside of it. The inside face of the cap. You can't select the outside. So here's what you do. Just glide over that, what looks like an ellipse here, where you know it's internal there. And you right mouse button click, not left, right click. And there's an option that gives you select other. Go ahead and select other. And you get a choice of different faces. When you see that internal face highlight in orange, in this case mine is face, the second one down, you're in good shape. Just go ahead and select it. And it should show you some arrows. Okay, and at this point, we're going to go ahead and actually, instead of pressure, we're going to make sure we select mass flow. And over down below here, we want to go ahead and we want to put in 25 pounds. So just type in 25 for the inlet mass flow. And we'll just leave it at the ambient 68 degrees Fahrenheit for the temperature of the fluid. Now go ahead and hit next. The little blue arrow. Now we get to add the outlet. Now for the outlet, we do the same thing. Just glide over that elliptical face because we need the internal face. And you're going to right click and do the select other option again. In this case, it's the first choice on mine. I'm going to go ahead and select that face, highlights in orange, and we see these arrows. And we're going to leave it at the 14.69, which is basically barometric pressure, the standard, what you'd find here on Earth. So there's really no back pressure or anything like that. That's beyond what we're just experiencing in a normal environment. So go ahead and hit the next button again. And you get to solve it. Hit this little play button for solve. Now it takes some time, depending upon how fast your computer is. It might take a long time, or it might be very quick. Again, it's the software does take advantage of multiple core processors, and also memory is a very big helper with this. For example, years ago I had done a job with a customer that I had, and they were taking 8 hours to do a finite element analysis exam on a simple foot pedal. Now this was a computational fluid dynamics, but it was a finite element analysis for a stress test. And just by doubling the amount of RAM they had, they changed it from 8 hours to 20 minutes for the time it took to actually complete processing of it. So RAM makes a big difference. I'm not saying get a ton of RAM, but if you're going to be doing these on a regular basis, the more you have, the better. So like right now, you're seeing the standard is almost between 4 and 8. You probably want 8, maybe even more gigabytes of RAM on your system in order to take advantage of it. This computer I'm running on is actually only has 4 gigabytes, and it's just a dual core netbook, so it's rather slow, so it takes a while. Okay, as you can see, it took a while to complete this, at least on my netbook. And what we get here is we get actually like little pipes as a preview of the vectors of the direction of our flow. On the left, we get in velocity, inches per second, the speed, because as it gets more narrow passage, it actually increases the speed. You can also go over here on the left, and you have the ability to adjust some of these settings. Like, for example, if you want to see pipes or balls, adjust the plot setting from based on the inlet or the outlet, or how many pipes or balls do you want to see. I'm going to go ahead and hit the play button right here, and we'll see a preview of the actual flow. You can see some areas there where it's blue, it's slowing down considerably, and then it's wrapping around, and so we see some chaotic flow, which is known also as turbulent flow. If you hit the stop button, you can change it to balls, and then hit play, and you could get an animation of that occurring. And you can increase the number of balls just by dragging this little, actually you first have to stop it, you can drag this left or right. And that completes exercise 3.